go.
So I'm Holton Ike. This is my presentation on the organic carbon content at a no-till farm in the Finger Lakes region in New York. So first I'll direct your attention over to the map here. Within the Finger Lakes region, my site was in Lodi, New York, which is between Seneca and Cayuga Lakes. You can see on the family farm here that we had 5 collection sites. I had a forest control site, as well as 2 cornfields and 2 wheat fields. So on the sample collection in August, we showed up after a minor precipitation event, so the soil was a little bit wet. We collected core samples that you can see we used this hand auger to do, as well as composite samples. And after we collected samples and they went through a drying period, we compared the wet and dry colors and then did a soil texture classification. I was able to calculate out the percentage of moisture that was being held in the soil samples, as well as the percentage of gravel after I put them through a sieving process to separate. And then I had some chemical characteristics with the pH and the electrical conductivity of the soil. You can see that my samples are a little bit on the acidic side of neutral. And then if I can direct your attention down to the main point of my study, this is the percent carbon that we were able to get. The carbon is a very good marker for the soil health, because in a short scale project, we wanted to see if carbon could help hold other nutrients in the soil, as well as increase water retention during the hot summer months. You can see that our forest sample on the graph had the highest percentage of carbon, which was expected, where you aren't removing any crops or anything, but you leave the leaves and everything to biodegrade. But what's important to see with the graph is all of my other samples, even though the forest samples started out a little bit over 6 to 6.5%, my other samples are in the same ballpark, going between 4 and 5.5% when we start out. The other significant thing to look at with this graph is that as we increase in depth, we don't see a very sharp decrease of the percentage of carbon, which means that with the soil horizons being undisturbed and not being tilled, we're allowing some of the carbon to stay in the soil and not be lost to erosion or other environmental factors. This graph over here next to it represents the 2 methods that I used to calculate the percent carbon. So we have the physical LOI, loss on ignition, and then our chemical digestion test. So the loss on ignition test is a burn test. The oven ramps up to a period at 550 degrees Celsius, and at that temperature it burns off carbon. So we can do a mass loss calculation to get total carbon and then total organic carbon. The chemical test is supposed to get rid of all of the organics using laboratory methods with wet digestion. And then we did the exact same thing. After a drying period, we did a mass loss. And with the 2 calculated and then plotted against each other, using this 1-to-1 ratio line, meaning that the exact same values came from both tests, our R-squared value is 0.988. So it showed that we have pretty good data and we were able to replicate it using 2 different methods.